Okay, this chapter now, guys, we're looking at chapter 7D on Pearsons correlation coefficient. Sometimes you'll hear it or see it being called the R value as well. Last lesson, we looked into more depth of association and how we actually describe a graph based on its direction, its form, and its strength. So remember the three options are direction. You've got positive, negative. In form, you've got linear, nonlinear, or no association. And in strength, you've got strong, moderate, and then weak. Okay, so now when it comes to this chapter, or for the previous chapter, remember we were looking at just by eye describing the association of these shapes. So just by looking at it by eye, for example, I can see that this graph here would be considered as positive. Okay, it's also linear. Looking at this graph, by the way, and it's strong. Okay, and I can tell that these traits are true based on what I can see here. Okay, based on just looking at it by eye. However, in 7D, instead of actually using our eye to determine the actual association, there is a numerical value that we can use to describe its association. Okay, and when it comes to this kind of question, numbers obviously have to be numerical and linear. But having a look at, for example, this graph here, this has an R value of 1. Now, 1 being the highest number you can have for R value, meaning that it's a perfect positive association. So it's a positive 1, which is a positive number, 1. Okay, also meaning it's a basically you can see it, think of it as like the most straightest a line could be. And you can see that the dots basically, okay, are a straight line. So this has a R value of 1. It's a positive, extremely strong, or even perfect strength, and obviously it's linear. This has an R value of -1, and you can see it's negative because the lines now go downwards. It's -1 as well, so this is the lowest in terms of negative, or highest in terms of negative you can go. And 1 meaning that it's a perfect line, okay, and it's negative, so it's a negative association, and it's also linear. Okay, this one here, this graph here, interestingly, now you can see when you start to have decimals for R values, you can see that now, yeah, the dots look a little bit more scattered. Okay, so this graph here, okay, will have an R value between 0.75 and 1. Okay, so obviously the lower the decimal number goes, the more spread out they will be. Here, similar thing, it's a negative association, and it's between -1 and -0.75 for the R value. Okay, and it's going down, and you'll see, like I said before, as the dots get more and more spread apart, the number for the R values start to get smaller. Okay, so for example, here you've got a 0.5, between 0.5 and 0.75 R value, and the dots are still positive. See, these are positive numbers, so that means the line or the dots will be going upwards, and the R value isn't as high as, say, for example, a 1 or a between 0.75 and 1, like these guys. Alright, so the R value here is between 0.5 and 0.75. And remember, if it's a negative R value, that means the dots will be going down. Okay, and you can see that this R value is between 0.75 and 0.5. Okay, on -0.75, sorry, and -0.5, so they're a bit more spread apart. And you can probably guess that for weak associations or weak looking dots where they're a bit more spread out, the R value again gets lower. So you can see that these are positive numbers, which means that it's a line that goes up, or you can see or make a line that goes up. And because the dots are more spread apart, the R value is quite small. So it's between 0.25 and 0.5. and the same with the negative. So just watch out. If it's a negative R value, remember that the line should be going downwards. And as we know, no association. Basically, it's a graph that has an R value between negative 0.25 and 0.25. Okay, basically, when you have an R value that is between these amounts, there is no association. Okay. Okay, so let's look at some associations and how outliers will affect the association. So if you look at here, this graph here will have an R value of 0.5. It may actually look like it should be more, okay, judging from the fact that these dots here are quite close. So you could say that they might be like 0.75 or 0.65. And I'm saying 0.65 because it's a positive graph or a positive direction for the line, so it should be going upwards, not a negative number. But it's considered to be 0.5 because of this outlier here. Okay, instead of having, for example, a graph where where if I was to draw a line here and try to represent this data where it looks like this, I now need to consider that dot here. So that line will actually be maybe more like this. And it's not a good representation, obviously, because the outlier affects all these guys. Okay, but if you were to remove the outlier, notice how the R value now increases. Okay, and it goes up to 0.7, which is what it should be. Okay, because most of the dots are here. Okay, so remember, the more further apart the dots become, the smaller the R value. Okay, so how do we actually calculate the R value in a graph? So you will come across a question where it says, okay, you've got these two variables and you need to find the R value. Remember, the R value can also be known as or seen as Pearsons correlation coefficient. Okay, is another word for the R value. Okay, Pearsons correlation coefficient. So we need to get a CASs for this. So on your CAS, go new document, or press the home button if you're not there. New document. Oops. If this happens, just press Control I. And then we're gonna go list in spreadsheets. So on your graph, what you want to do is you're gonna have two columns. Okay, actually, even before that, let's look at our two variables here. Okay, let's understand the scenario and what EV and RV might be. So what's the explanatory variable and the response variable? So I can see here, umbrellas sold and rainfall. So which one is X and Y, or which one is EV and RV? Well, does the umbrella sold determine the amount of rain, or does the amount of rain determine the amount of umbrellas sold? Okay, obviously the rainfall should determine, so explain the umbrellas. So you could also say that rainfall, the cause, is the effect of, the effect of rainfall, okay, is umbrellas sold. So cause and effect is also another way you could think of it. But in this case, EV, rainfall, causes the RV to change. So on our graph for our CAS, let's consider what we need to put on our variables. So I can just put umbrellas here if I wanted to. Let's make that bigger. Umbrellas here, but just remember that umbrellas is the RV and rainfall is the EV. Okay, and then under umbrellas, I need to make sure I put the correct numbers. So go ahead and put these numbers in, going down through umbrellas, and once you've done that, go ahead and put rainfall in for the correct numbers as well. You can skip ahead to the next part for this, but I've already done this already, so I'm going to open a document that says umbrellas. So I've already got my numbers here. So once you've got your numbers, so I've got umbrellas, rainfall, put my numbers in. Now we're going to calculate the R value for this. Okay, so to calculate the R value, this is going to be slightly different to how we calculated the 5 number summary. wherein we do go menu still, we go statistics, stat calculations, but instead of one variable, okay, you're going to go a plus bx, so number 4. Okay, I'll go over that again. So from here, we go menu. So this is what we do to calculate the R value. Menu, statistics, stat calculations, and then we go a plus bx, so number 4. Okay, so remember here, X list, Y list. So remember what's in your EV, what's in your RV. My EV was the rainfall, my RV was the umbrellas. So go OK, and I can see now, so my data's here. If you go to the right a bit, here is the data that we're looking for. So the R value is basically the letter that has the R there. So here is my R value, 0.710603. So the R value here, 0.7, I think it was just 10. So just leave it as 1 for the R value. That means if I was to make a graph for this, the R value would be 0.71, so it's positive. It's probably going to be moderate, and it's linear. Okay, so what is the R value for? So the R value measures the strength of a linear relationship with large values indicating a stronger relationship. So that means this R value just measures how strong the relationship is between two variables. Okay, with your R value, your values can actually only be between -1 and +1. So you can never have an R value of 2, 3, 4, 5, 6, 7, or -2, -3, -4. It's between -1 and 1. And generally, okay, you'll always have a decimal. Okay, so a decimal like 0.9, 0.33, -0.1, those kind of decimals. So R values, if it's positive, okay, obviously it's going to have a positive relationship. So it means it's going upwards. Okay, and then if it's negative, it's going to be linear, it's going downwards. Okay, the R value can also be interpreted to figure out what the association is. So remember, association talks about the direction, the form, and the strength. So you can actually derive direction, form, and strength from an R value. Okay, generally as well, when it comes to an R value, you have to interpret it in these forms, or in this sort of, with these words. What's the strength, what's the form, what's the direction? So if you have a look here, if you have an R value between 0.75 and 0.99, it's considered to be strong, positive, and linear. Okay, strong, positive, linear. If you have an R value that is between 0.5 and 0.74, it is moderate, positive, and linear. Okay, if your R value is between 0.25, 0.49, it's weak, positive, linear. Okay, and if your R value is between -0.24 and 0.24, there is no linear association. So, or in other words, no association. And similarly, if your R value is between -0.25 and -0.49, it's weak, negative, linear. So remember, if it's a negative number, it's going to be going downwards. So it's a weak, negative sort of direction. If it's -0.5 and 0.74, it's moderate, negative, linear. And if it is between -0.725 and 0.99, it is strong, negative, linear. Remembering again that if it's a negative number like so, or like these guys, okay, the line should be going in a negative direction, or the dots should be going in a negative direction like that. Okay, so just some examples. Let's say my R value is, actually, let's have a look at the R value up here for the rainfall. So I can see the R value for rainfall and umbrellas is 0.71. So if I look at the scale here, or these numbers, where would 0.71 fall in between? So that would be in between 0.5, and 0.74. And I can see that the association for any R value between that is moderate positive linear. So as an answer for this R value, I would write there is a moderate, oops, let me fix that. There is a moderate positive linear association between, okay, and you'd write your EV and your RV. So the EV was rainfall in millimeters, and the the RV, sorry, and umbrellas sold. Okay, that's how we interpret the R value. Let's move on. So correlation and causation. So in this section, we're going to be going through something that's not really too mathematical, but where it's still considered to be in some ways related to what we're doing. Okay, so generally, when you have a strong association between two variables, whether it's positive or negative, doesn't always mean that there is causal association, meaning it doesn't always mean that one actually affects the other, or doesn't mean that there's a relationship between the two. For example, here, the number of people from each year in 2000 to 2009 who died by becoming tangled in their bed sheets in the USA, and the total revenue generated by skiing facilities in USA over the same years have correlation coefficient of 0.969724. So what this is saying is, as the total number of people who died in their bed sheets increased, so did the number of money generated by skiing facilities in USA. Okay, there was a correlation of 0.969724. So if I tried to graph this, what this is saying is, because it has such a high R value, and let's just call this, for example, ski, and this is deathbed. Okay, so people die. So the graph, if you were to graph this, so it has an R value of 0.9, meaning that the graph should look something like this, almost. Now, this is just random. It's not very straight, but the graph will look like this. Now, if you think about it, does skiing, okay, cause people to die in their bed sheets, or does people dying in bed sheets cause more people to ski? Now, it doesn't make sense, okay, and that's what we're looking into here, where sometimes just because two variables have a high R value, or there is a strong positive linear association between the two, does not mean that it actually one causes the other. Okay, and this is what causation is about. So in terms of explanations for what they might be, you have four. We already know what the first one is. Okay, so for example, causation is one option where we already know that one variable might cause the other. So for example, if we look at the previous example prior to this one we did about rainfall and umbrellas, obviously, okay, this is definitely causation, because we know that rainfall causes more people to buy umbrellas. Okay, so that's already an obvious one. Causation, meaning that one causes the other directly, and we know it. Common response, okay, so let's say, for example, a graph might have something like this. Okay, it goes like that. Okay, might have a high R value. And for example, it could be chocolate, and this could be yogurt, for example. Bad spelling, but yogurt. So in this case, okay, the more people bought chocolate, the more they also bought some yogurt. But is there a correlation between the two? Well, who knows? But there is what we call a lurking variable that might actually be affecting both of them, which affects both variables to change. Could be, for example, that milk is a lurking variable, so the quality of milk maybe got better, so more people are buying either more chocolate or more yogurt. Who knows? But lurking variable that we might not necessarily know. So that is what we call a common response, where something, a lurking variable, affects both variables. Confounding, okay, it's unclear. So here it's unclear how the variables are related, and we aren't able to draw conclusions about causation or common response. There may be a confounding variable, meaning that there could be something we don't know that is causing both of those variables to actually have a strong R value. So let's say something like this. Okay. And I don't know what variables you could have. Let's say, for example, trees growth. And maybe in this one it could be animals, number of animals. Okay, again, it could be a variable that's affecting both, but we don't actually know what it is. And we can't draw any real conclusions between what it could be. Unless maybe you did some tests. But confounding means for both variables, okay, it's very unclear as to what is actually affecting them. And coincidence, an example of that is basically this one here, where I don't think that the amount of people dying is in any way related to the amount of money made from skiing. So it's just purely coincidental that both of them have an actual strong R value. Okay, that's basically it for chapter 7D. Hope you guys got something out of it. Go ahead and do the exercises for 7D, which are, I can show you guys here. Questions 1, 2, 3, 4, 5, 6 for 7D. Okay.